My screen is visible, ma?
Yes, sir.
Okay, good morning, good afternoon, all of you. We will see today a continuation of previous class. As we discussed in the previously, there is a support vector machines types. In that, we discussed two types, or you can say the two classifications. One is the linear support vector machine, another one is a non-linear support vector machine. So, in that, we have discussed already. There is a linear support vector machine with some examples as well. Only the difference is more or less same only. The thing is, if it is non-linear, we cannot segregate the classes separately because it is uneven. Uniformity will not be there. That's what once if you try to make a classification, or you can say that hyperplane, if you want to draw, that should not be divided properly. That is the reason we go for some other mechanism in this case. So in a nonlinear support vector machine, we'll see the problem as well. So what we have is the points as usual. There is a positive labeled data and then negative labeled data. So two positive and negative labeled data are there. So what we have to do is we have to make a plane first. As per previous linear support vector machine, now also we have to make it as a points in the x-axis and y-axis. We have to take it, and the x-axis something like this, and y-axis and 2 2. So x-axis is 2 and y-axis is 2, and then this is 2 and minus 2, something another point. Another one is minus 2. Now the x-axis is minus 2 and y-axis also minus 2, something. So like that, we have to put the points. Whatever the data is mentioned here, in the same data, we have to provide the plane, xy plane. Now this is the thing. Now we can see here there is a non-linear support vector. After placing the positive and negative points, we can observe that this is the 2 2, because the points is mentioned 2 to 1 point. Another one is 2 minus 2. This is the 2 minus 2 point, and third point is minus 2 minus 2. So let it be, you can see x-axis is minus 2 and this y-axis also minus 2, and another one is minus 2 plus 2. So this is minus 2 and plus 2. Now we have placed all the 4 points. Similarly, we can see other negative points as well. There is a negative points in the negative labeled data point 1 1 1 minus 1 minus 1 minus 1, like that. So there is a negative labeled data points also we placed. So this is the 1 point, and there is another point, like that. We have all the 4 points, because you can see here there is a 1 1. What is 1 1 point? This is the 1 1 point. Another point is what? 1 minus 1. You can see 1, there is a minus 1, second point. And third point, minus 1 minus 1. This is the third point. And fourth point, minus 1 and plus 1. This one. So like that, we first step is this one for any, whether it is a linear problem or a non-linear SVM or anything. First, whatever the data is there, you have to represent in terms of the points only, just to make it. Then what we have to do now by observation here, suppose I want to draw hyperplane. So wherever if I want to draw the hyperplane, it will not be divided properly. Suppose if I draw this, there is a mixture of red as well as blue. So or if I draw any line, if I draw, it should not be as a proper hyperplane. That is the reason optimal hyperplane in this non-linear SVM case, the distribution is not uniform. In that case, it is difficult to draw as hyperplane straight away. That's why what we have to do is we have to, this is what whatever I mentioned so far, the positive label and negative label are separatable. So we need to convert this into another feature space. We have to create a one more space. How to do that to get the hyperplane data points into 2 points. So what we have to do is we have to divide this total hyperplane, one more plane you have to create like a 3D and upper side and lower side way we have to get it. So we are these points you have to convert it into one additional plane by make use of this relation. So now we can see our goal is to again discover the separating the hyperplane. So what is the separating hyperplane? Two classes are there, no, red as well as other blue something. Suppose that two has to be divided properly. That is the optimal hyperplane. That is only the our case. So accurately I have to divide two classes. In the previous one, what we do is existing in input space. So it is obvious that no such hyperplane is existing because in this diagram, if we want to draw any hyperplane, it should not be directly divided. That is the reason that is a difficulty. So in that, what we have to do, we must go for as a nonlinear SVM and convert into this form. So there is a data pointer, this let it be x1 and x2 for a first positive, whatever they given the problem, we have to convert the total data point into this fashion. So what is this non-linear SVM model? In that case, suppose you can see first data point 2, 2 is there. What I have to do is this 2, 2 point you have to convert it into this formula. Phi of 2 comma 2. So phi of 2 comma 2, what is the value you are getting? That value you have to put it into plane. Now we can see. So in that case, there is a two formulas we have. This is one formula. There is another formula. What is first formula? If x1 square plus x2 square root is greater than 2, then we can say that it is a, you have to use this formula. X1, X2 values will get it from the mean. This data is going to be modified according to this point. Otherwise, you have to use as such value. So if this is not greater than 2, then what you can do, your values will be similar to this. Now, first point you can see our data points are given positive data points and negative data points. So first positive data point is 2 and 2 is there. So this 2 and 2 we can convert into this fashion. So what is the 2 square plus 2 square? So here 4 plus 4 root. Then it is greater than 2. Or suppose some other case, we can see if it is a less than, then you can use as such value. So what will happen? Root 8. So root 8 value is always greater than 2. So that is a 2.8 something. That's what now I have to use this formula to get new data point. Now what is the formula? 4 minus, what is x2 value? X2 value is 2 and plus modulus of x1 minus x2. What is x1 minus x2? 2 minus 2, 0. So then your value is equal to 2. In this case, first point is 2. And similarly, this is x1 point, this is x2 point. And next we can calculate 4 minus x1 is 2 and plus x1 minus x2 modulus. That will be 2 minus 2, 0. So again, this value also 2. But of course, in this case, whatever the new value, I mean, old value is 2, 2, but new value also got 2, 2 based on the value. But normally, it may not be the same always. So it will get it as some other values. That value you have to put it into plane. But now one point we calculated like this. What is second point according to here? Second point is 2 minus 2. Now, how to find 2 minus 2 point? So this is x1 is 2 and this is a minus 2. Then what is this x1 square plus x2 square? Again, it is a greater than 2 only. Then what is second point? Here we can calculate 4 minus what is x2 minus 2. So minus minus get plus 2 and then plus x1 minus x2. x1 is 2 minus minus get plus 2. So 4. So this will be 4. So totally 10. This is first point. Then what is second point? You can see 4 minus 2 right here 4 minus 2 and plus what is x1 is 2 minus minus get plus let it be it is a 2 plus 2 4. So 8 minus 2 then it is a 6. So now new plane is a 10 6. So whereas earlier 2 2 point you got it as a 2 2 only, but now 2 minus 2 will get it as a like that. What you have to do is you have to get all the new data points like this. Now that's what just explanation. Now suppose if any point comes, some other point, let it be 1 1. What is 1 1 1 square plus 1 square 2. So that is a we can observe that what will happen if it is a points are root 2 case. So here if I use the root 2, it will be 1.4 only. So in that is a it is not a greater than 2. That's why you have to go for value is x1 and x2 only. That is what we got it as a 1 1 only here. Like that, whenever if it is greater than 2, then only you have to use this formula. Otherwise, the value will be the remain same. So like that, if I calculate 2 comma 2 in this formula, I got it this one. Then again 2 comma minus 2. Again I got it this. So like that, again minus 2 comma 2 in this we will get this. So minus 2 comma 2. So all the points are modified here. Positive points. Similarly, negative case also, what will happen? These are all ones. If it is 1 square plus 1 square root 2, that will be as a less than 2. That's why the otherwise case, these points will become as a, these are the points. Now, what we have is, we got it as a new points based on your phi of x phi 1 of x comma x1 comma x2. Now we have to represent the table. I mean, in the sense plane graph. So if I draw this points, whatever 2 comma 2, 10 comma 6, 6 comma 6, 6 comma 10 and so on. If I mention this point, now by observation itself, it is very easy to segregate. Now earlier, the red and blue are mixed. Now in that case, hyperplane is not optimal hyperplane is not possible to draw. But now, whenever if I draw, there is a what you call it as by make use of nonlinear support vector machine, we are able to get see that this is all we can observe one portion is a blue and these are all other portion is a red. It is easy to draw as a hyperplane like this. What will happen if I make it one line, hyperplane line, something like this? Then what will happen? This is our optimal hyperplane. This portion is a one group. This is a another group. So that's what two classes. Let it be. This is a class 1. This is a class 2. So how these line now from this point onwards, it is similar to linear support vector machine only. So only earlier it is a non-linear form is there. Now you have to convert non-linear to the linear by make use of our formula and our another plane. We can able to get it by seeing this we are able to segregate. But while we are segregating, lot of lines are possible to draw. but whatever may be the line, which line is an optimal line, we can able to segregate. For that, as usual, support vector algorithm only you have to see. Now you take it as a, what is next step? So first step we place. Now it become as a linear only. Now the procedure is similar to that of a linear. So what is the linear point? This one is a linear support vector machine. We have to identify 2 points which is near to each other. That's what I mentioned here. We can easily divide the positive and negative points now, but while you are dividing, where to divide? That's what we need to get the values. And that value, if you draw as a line, that is going to be divided. So we need to identify the positive data point and one negative data point near to each other. So which point is near to each other, positive and negative data point? Like yesterday, we drawn two vertical lines. It is boundary, extreme points of that. So what is extreme points here now? These two are the extreme points. Now this is one line, or I can say that one point. This we call it as a support vector. This is another support vector. Now we got it as a two support vector with point of, this is one point. There is another point. So what is positive support vector? 2, 2. This I call it as a, let it be S1 is equal to 2 comma 2. Similarly, what is S2? There is another point that we call it as a 1 comma 1, I think 1 comma 1. This point. This point is a 1 comma 1. This point is a 2 comma 2. So this is the way we can able to get the first support vector. After that, this is related by the second step. What is third step? First step is, in the case of linear, you have to draw as a plane. After that, you have to go for a select the support vector, then add the bias, and then you have to proceed. But now the first step is again same. You have to draw the plane. Second step in this case, you have to convert in another plane by make use of phi of x1 comma x2 formula, and it will convert it. After that, again steps will be the remain same. Now we can see, we know x1 and x2, any is correct, nothing is wrong. This also you can take it as x2, this may be s1, this may be s1, this may be s2, anything. So 2 points is required. The 2 points you can able to make it as a support vector. So this support vector 1, 1 comma 1, support vector 2, 2 comma 2. Now we have to add the bias. So we already solved yesterday 2 problems by adding the bias. Now this is going to be as a bias for support vectors. So each argumented we added as a one is a bias. After that, this formulas are again same. If it is a 3 support vector, we will get the 3 equations. And if it is 4 support vectors, we'll get the 4 equations. Like that, we can able to get the support vector. This is support vector 1. This is support vector 2. And in that support vector, alpha 1 S1 into S1 plus alpha 2 S2 into S1, that is equal to -1. And alpha 1 S1 into S2 plus alpha 2 S2 into S2, that plus 1. These are the 2 equations. So now if you make it as a 2 equations and you substitute what is the S1 value, S2 value in this, and you can see that alpha 1 S1 is 1 comma 1 comma 1, and again S1 same, plus alpha 2 S2, then S1, that is equal to -1. Why I call it as -1? This I consider because of the, as per the diagram, 1 comma 1 is this one. This is a red. So it is a negative plane. This one will be positive data. That's why this will be -1. This will be -2 as per our formula itself. Now we'll make it as a -1 and +1. And 2 equation. This is one equation and this is another equation. So 2 equations and 2 unknowns. We'll get it as a value. Alpha 1 is -7. Alpha 2 is equal to 4. So now we can able to get alpha 1 and alpha 2. Once if we know alpha 1 and alpha 2, we can easily calculate the weight function. So what is this weight function? Alpha 1 into SI. What is alpha 1? -7 as per previous. See that this is the alpha 1. there is a minus 7, alpha 2 is a 4. Now minus 7, S1, this is the S1 plus alpha 2, S2. This is alpha 2, S2. And if I multiply these two, we'll get it as a 1, 1 minus 3. Now what is 1, 1 minus 3? Minus 3 is a bias and 1, 1 is a line we have to draw. So that's what finally our vectors are augmented with a bias. This is the bias as per our formula. Y is equal to Wx plus b. W is here weights. There is a first weight and second weight. That means x1 and x2 points. We'll get it. And bias will be minus 3. So this is the bias will be minus 3. Now we got W vector as well as bias vector. And bias is 3 in the sense it is going to be cut the axis 0.3 and 1 1 means the slope is 45 degrees. So now we can get it. This 1 1 line is going to be cut at 3. You can see this is the 3. This one is 3. So 3 3 it is cutting. Now we can see this is all about one class. This is all about other class. This is the optimal hyperplane. That's what I mentioned. That line I call it as hyperplane. The whatever this blue is a positive and red is negative. And which one we selected as a vector, support vectors. These two are we call it as a support vectors. That is only the representation to understand which elements you are going to select it as a support vectors. These are the problems. So now this is the way we can easily solve the problem like this. Now what you will do is you take any of the problem from this unit. Later point of time we'll go some more algorithms. In that algorithm, you take one of the algorithm and try to submit the assignments. So any after this class, I will discuss that point as well because one unit is already completed. This is second unit we started, and this also more or less many topics are covered. And after SVM, we'll start with another algorithm like 3 4 algorithms are there. We'll complete these algorithms with problems. Now, if you understand this problem, what is the advantage? We can take this real-time problem and you can use your either MATLAB programming or Python programming. You can able to solve this automatically. If you execute this, that is going to be draw as a line like this. So once if you give them data and you try to develop a MATLAB code or maybe Python programming, obviously you will get it the this kind of table or plane, that line, what you call it as optimal hyperplane line is going to be drawn through Python programming or even MATLAB programming as also fine. No. So there now we'll move on to kernel tricks in support vector machine. What we noticed in the case, some cases the data, anyhow that will let you know in the next slide and all. The data may be text or image or video. So this type of data will be there. So there is a need to extract feature from these data prior to classification. So whatever data is available, suppose the data points are given to you is the problem is like this. Thus is not possible to draw normal line. Suppose if I draw one line here, it is not divided two classes separately. If I draw a line is here, this is also not possible. Or if I draw any line, we can able to observe this is not possible to clearly segregate your two classes. So that is the major problem. That's why because of the normal data, it will be like this only. It will not be separate the classes. So what we need to do is, so all real world problems or any classification models are complex and most required non-linear hyperplanes only. This is what we ought to identify. So we can see that wherever the data points are there. Now, if I able to draw this type of line, hyperplane, what is happening? These are the blue is one category and inside red is another category. So blue and red. We are dividing the hyperplane such a way that so it is not possible directly to draw such kind of lines. So what we have to do, we are converting this to this plane. Whatever points are there, these points, all points, these points we have to make it as into 3D plane. Now we can observe in this plane, if I dividing the line is like this in this plane, so upper side is all it's showing to as a blue, lower side it is showing as a red. So it is a division is very clear if I convert the data into this form. That's what I'm mentioning here. Two classes blue and red is to classify data. We cannot draw straight line because in the earlier in the linear plane and all we can able to draw single straight line or hyperplane. Based on that hyperplane we are dividing this portion is a one class, this portion is another class. But now what will happen if I divide like this directly, this portion is mixing of red and blue, this portion also mixing of red and blue. Therefore, so what we need to do is, it is not possible to draw as a straight line to divide two classes. That's the reason what we are doing this non-linear data into linear data. We have to convert this non-linear data to linear data or 2D data to 3D plane with this conversion. So how it is going to be converted, for that I will show you the formula as well. So whatever 2D data is there, you have to convert to 3D data so that the classification is easy for you. Now, but you have to convert input space to feature space. You have to convert that point. So all the points you have to convert. Now what is happening? Mapping function. We are using as a phi is a mapping function. Convert non-linear data to linear data. That will call the feature space here. So non-linear data to linear data. That will be called as a feature space. So mapping function is depends on the data set. So based on the data set, we have to go for as a mapping. For that, we have as a formula. Now we can see that the phi, we have to convert 2D data to 3D data. So we are giving 2D data to 3D data, phi of x comma y, this is equal to, this is the formula you have to use it to convert 3D data. Because in the 3D plane, what we require is all 3 points are required, x, y, as well as z. So this points to get as a 3D data, we have to what is x point, y point, and z point. Correspondingly, you can able to put a point. So that is what whatever the plane is given the data, xy data, you have to convert it into 3D data. And now the suppose if the xy point, any of the points, suppose this point you take it, or maybe this point or this point or any point if you take, that data is suppose it is a 2 comma 3. If the data is 2 comma 3 and substitute here, so what is happening? 2 square, then it is a 4 plus root 2, the substitution only, I'm not doing anything, x comma y. So 6x into y means 2 into 3, 6. That is 1 point into y square. That will be as a 9. So now this is the new point. So where you have to plot, you can see that 4, that root 2 into 6, I can write it as a same thing. That's what 6 root 2 and 9. This is the new point is arrived. Once new point is arrived like that, you have to convert all the points using this formula. Now, if I do this way, means 2D to 3D plane, mapping plane is important role. There is a many disadvantage involved, more computational cost. Because if it is only, suppose very few data points are there, you can use this formula to convert into this plane and you will go for the division, I mean hyperplane. But the problem is the data points are not this many. Lakhs of data points also there because it is all about the data sets, whose data sets data is available. Now for each one, you have to go for this thing is a little bit is a complicated one. So that is the reason I'm going to convert instead of this. We can observe what is happening. So that is the reason. Just a minute. Yeah. So there is a that is what the disadvantage. So disadvantage of transformation is that there is no generalized thumb rule available. So to transform the large data set. In the real application, what is happening may be many features as huge data points are there. It is the computational cost will be very, very high. This is the only kernels are useful. So now we are going what I explained so far in the normal non-linear plane, you have to take it as another plane, make it as a conversion from non-linear support vector to the linear support vector form. That's by make use of the formula. But now there is a kernel trick is there. By make use of a kernel trick, we can reduce that computational all these things. You don't want to go in that fashion. We may have another procedure as well. So in that case, the kernels are set foundation to be used transform data from lower dimensional to higher dimensional data and to manipulate the data using dot product at high dimensions. Now we have to convert that low dimensional data to high dimensional data to produce conversion process. Use of kernels is applied transformation to data to perform classification at higher dimensions. Now we can see low dimensional data is there. You're using as a kernels. This kernels will be there. The lot of classification. I will show you the different kernels as well. And what it will do, low dimensional data to, it will move to high dimensional data. Now it will go for the support vector machine. Yesterday we solved some of the problems in the support vector machine as well. And now we can, if any test data comes, it will give as a predicted output. So in that manner, we can able to convert. Now we can see what is the kernel trick. Now earlier we used this formula to convert low dimensional to high dimensional set. But now if I use the kernel trick, this manipulate, what we call it as calculation part, every point we no need to calculate like this and you have to put it. We are going with one formula is a kernel trick. This is the formula of a kernel trick. Phi of A transpose into phi of B. Now if points are there A and B, or let it be A1, A2, B1, B2 like that, 2 points are there. What you are doing, we are using this type of formula. How that appearance we are getting, final appearance is simply A transpose into B square. That is only kernel trick. How you got it? So this is the formula as per this only. But we are simplifying that using the kernel trick. This is the individual point if we want to do. It will take us a lot of time. Each point you have to convert into this fashion, two-dimensional to three-dimensional, and that three-dimensional you have to represent in the plane. But now what will happen x square? Now x square means here let it be A and B you consider. Then let it be A1 square and then root 2 into x comma y. Then root 2 into A1 into A2 points. I'm telling here A is A1, A2, B is B1, B2, 2 points. So how we are converting into kernel trick for 2-degree polynomial mapping. So now another one is a y square. So here y square means let it be as A2 because I consider A1 and A2. A1 and A2 is nothing but a x comma y. In that case, you can able to get it this point transpose because phi of A transpose into phi of B. So phi of B is a B1 square and same. Now instead of A will become as a B because another point x square. Now that is nothing but a B1 square and root 2 into x1 comma x2 root 2 into x1 comma x2 and y square. So y square is nothing but a this b square. Now these two will be as a arithmetic mapping we have to do. If I do arithmetic mapping, we got this expression. What is this expression? This is nothing but a let x and let consider this is x square plus 2 into x1 and x2 plus I mean x or y, x and y let consider. So x square plus 2xy plus y square. This is nothing but a plus b whole square form. Now we make it as a plus b whole square form. So now this is arithmetic operation. The a plus b whole square form means here a1 b1 plus a2 b2 square. I can write like this: a1 a2 transpose in dot product b1 b2 whole square. This is nothing but your final kernel trick. So formula. I will show the examples also. Instead of each point you are using this, we are able to do directly as a one step here. That's what I'm previous slides, what we shown you is mapping phi of x comma y. You have to use this formula. Phi of x comma y, we make use of this formula. That is a complicated. Each data point we need to apply this equation to get data point. But it is a costly because thousands lakhs of data points are there. Each data point we have to use this formula. It will be as a costly manner. That is the reason we are using as a kernel trick over here. What is kernel trick formula? This is only your final kernel trick. This is nothing but you make use of whatever points are there A and B, A transpose into dot product of B whole square. It will give as a kernel trick. So now doing this, we saved the lot of computational cost and learning time. So it is directly one step we are able to get it as a your higher dimensional, from lower dimensional data to high dimensional data we are able to get it. So this is the most useful or advantage when we go for as a instead of going for transformation there. Earlier what we are using as a mapping function phi of x comma y is mapped to x square comma root of root 2 into xy comma y square. So instead of that, we'll go for as a kernel. Now there is a different types of kernels. So, but in our case, simply we'll discuss only the what are the classifications of kernels and small problem, or I can say that small equation. That is all about the support vector machines in supervised learning algorithm. In the first kernel trick is a linear kernel and the polynomial kernel and exponential. By name itself, and the formula is going to be changed. Linear formula will use, here polynomial, and here exponential formula will use homogeneous kernel. And then inhomogeneous kernel, Gaussian kernel, sigmoid kernel, like that we have as a radial bias function kernel. So like this, we may have the different kind of kernel trick. Why we are using this kernel trick? We have to convert that low dimensional data to high dimensional data in non-uniform case. So to draw as hyperplane, it is easy to draw once if we convert this linear, I mean non-linear to linear form. Now, one by one, we can see first one is linear and then polynomial, exponential, like that. It is only the small formula, nothing else. A linear kernel. So this is the formula we are using as a transformation. Whereas earlier I already shown you the kernel generalized formula we got it. A transpose into B. So this kernel, we got it A transpose into B square. So that is a linear kernel we are using there. But I mean, normal formula, we can see that A transpose B whole square is your kernel trick. In that, we have different types. Suppose if it is a linear kernel, what we can give x comma y. So earlier fashion only, but here linear kernel means x transpose into y. Whereas earlier, A transpose arithmetic dot product B whole square is your kernel, but linear kernel means X transpose into Y we are using. X and Y are the two vectors. and then x comma y. This is nothing but a phi of x into phi of y, because 2 points we require now, x comma y. That directly you make use of this formula. Whatever x points are there, you make use of transpose of that dot product of y. If I make use of x transpose into y, that will be, I call it as a linear kernel. Now another polynomial. So what is polynomial here? Same fashion, x transpose into y or power q. So here q value, based on the q value, we can call it as a, suppose here q is a degree of polynomial, because polynomial may be second degree or third degree, something like that. That we can use q if q is equal to 1. Q is equal to 1 is called as a quadratic this polynomial. In a polynomial, q is 2 means what is now, it will become x transpose y power q. Q is nothing but a 2. This is a power 2. X transpose y into 2, that we call it as a polynomial kernel. In that q is 2, that is the reason call it as a quadratic. Another one you can see, same polynomial kernel. This way also you can write C plus x transpose y into q. Now, what is happening here? If suppose C is 0, then it is similar to previous one only. No, if C is 0, if I make it, this portion is 0, then x transpose y power q is nothing but a polynomial. If q is equal to 2, that is nothing but a quadratic polynomial. This is only thing will become when if c is equal to 0, because your function nothing is done. C plus this I wrote. So if C is 0, then automatically they become as a polynomial kernel with q is equal to 2 means quadratic polynomial kernel. That's what I mentioned here. C is the constant, q is the degree of polynomial. If C is 0 and degree is 1. So now if suppose q is equal to 1, then what will happen is a linear kernel only. What is our linear kernel as per our previous one? A transpose into B square. You can see that A transpose into B whole square. This is what we have. We can see the linear x, this x transpose into y. Earlier, A transpose B whole square is a normal kernel. So conversion phi to this aspect. But now in that we have as a linear kernel. Linear kernel is what? Same formula. If you make it as a cube, that become as a next one. That is a polynomial kernel. You can see q is 1. This become as x transpose into y only. If q is 2, x transpose y is power 2. That is a quadratic polynomial. And suppose c plus x transpose into y into q. Now we will get all the three from this. When if c is equal to 0, q is equal to 1, this is a linear polynomial. If c is equal to 0 and q is equal to 2, it is a quadratic polynomial. Like that, we can see that the value of degree should be optimal. More degree may lead to overfitting as well. So overfitting means what? As per previous, the first unit we discussed. So in the training data, it will perform well, and testing data, it will not perform or perform poor. That we call it as a overfitting. Now we can see that overfitting means classifier works perfectly on training data, means it will perfectly work on training data but fails on testing data. That we call it as a overfitting. That also we discussed in the first unit already, overfitting and underfitting and all. So in this overfitting meaning is we can, it will perform, the system or a model will be perform very well under training set, whereas and fail, training data, but fails on the testing data. So in the training data case will be perform well, and testing case it will poor. So we need to select the value of q optimal in nature. That itself as a one optimization algorithm, we can use it to find the optimum value of q, and then you can use that kernel trick then the total data set is going to convert low dimensional data set to the high dimensional data set. So now if we select more value of Q, there will be as a possibility of overfitting. That's what we have to select Q such a way that that will be as a optimal value. Otherwise, it will leads to as a overfitting. Now we will take simple example to understand this concept. We can see, consider two data points. What is data point 1, 2, X data point, and Y data point is 2, 3. So 1, 2 is one data point and 2, 3 is another data point with C is equal to 1. Now, what is meaning of C is equal to 1? As per previous formula, what they mention is C plus X transpose. This is what we discussed so far into Y whole power Q. This is one of the type of a kernel. What is the type you can see here? This we call it as a inhomogeneous kernel. This is a inhomogeneous kernel. So in that same formula, you can see X and Y is given, C is given as a 1. So C is 1, apply linear homogeneous and inhomogeneous. So if C is existing, then I call it as a inhomogeneous. What is the linear homogeneous? Linear homogeneous means Q is equal to 1, C is equal to 0. Then we call it as a linear homogeneous. And C is equal to 0, another case, C is equal to 0 and Q is equal to 2, then there is a homogeneous, that is a second one. So what we discussed here in the second one, quadratic kernel. So Q is equal to 2 means quadratic kernel and Q is equal to 1 means linear. Another C is equal to 0 and Q is equal to 1 is linear. C is having some value, let it be as 1 or 2 something. Then I can say that inhomogeneous kernel. So in that aspect, I'm going to calculate one by one. Suppose if you apply linear kernel. So linear homogeneous. What is formula for linear? This is only the formula for linear. So what is X? X is 1, 2 and you have to use the transpose and y is equal to 2, 3 and q is equal to 1. So therefore you can use q is equal to 1. Thus we call it as a kernel, linear kernel. So this is the one we got value is 8. Instead of using these data point, we can easily replace with the 8 is our kernel. So now q is equal to 2. So if q is equal to 2, called as a homogeneous, or we can say that quadratic kernel. So inhomogeneous means what? C is equal to something. So now C is not mentioned. We used q is equal to 2, that we call it as a quadratic kernel. So formula is same, only thing is here we make it as a 2. That will become as a 8. And another one we can see inhomogeneous. So here 3 examples we cover with the same data point. One data point is 1, 2 and y is 2, 3. This data point you apply here, you can able to get it as a homogeneous points. So now we can see C plus X transposed into YQ. C is 1. Now we got it as a, this is the value of inhomogeneous, then homogeneous, then linear kernels. Similarly, there is another kernel also there, Gaussian kernel. So this Gaussian kernel, so that is a radial basis function. There is another name for this is a radial basis or a Gaussian kernel are extremely useful in the normally this kernel, this formula will be used instead of previous one. This Gaussian kernel is a very superior when compared to the other. Normally all support vector machines will use as a Gaussian kernel, radial basis functions. This is only the function. Instead of that formula, we make use of this formula. That's all. So now x is there, y is there. If we substitute here, we get it as a value. Here y is the important parameter. If y is small, then this RBF. So what is the RBF? Radial basis function. This radial basis function is similar to as a linear. If y is large, then kernel influenced by the more support vectors. Then R base perform dot product, and therefore it is highly effective in separating the classes and often. That's the reason normally, as I mentioned, this Gaussian kernel will be more effective to separate as a two classes. This may be one class, this may be other class. Using this Gaussian kernel, we are able to draw as a hyperplane in that. Now consider x point and y point, and there is a formula in that sigma is mentioned is 1, and apply this Gaussian function, then you will get it as a new value is equal to this one. And if gamma is equal to 1, then kx comma y. Earlier, you can see that 1 minus 2 whole square. This is the square distance between the 2 points. So there is a for that also a equally distance point like that different kind of distance you can able to measure. And by using this, we'll get it as a what is your kernel. So this kernel we call it as a Gaussian kernel. Similarly, sigmoid function also there. In the sigmoid function, normally this also very efficient. The sigmoid kernel, only the xy is there. No, in that you can use tan h of k x comma xi y minus sigma. If we can use this formula, then we'll get it as a kernel value. So like that, we'll able to do these types of kernels. Now we can recall the things. So whatever we discussed so far, that will brief it in the case of what uh, so what we'll do is support vector machine. It is very important. This will work for both cases, regression as well as the classification case. Now, in that we discussed how to solve the problem using support vector machine. In that linear support vector machine and then non-linear support vector machine. Like that, we are able to divide this classification, and each classification we covered some of the topics as well. I mean problems, how to solve the linear support vector machine problem as well as the non-linear support vector machine problem. After that, there is a mapping. We can see that it is a non-linear case. The data points are is not uniformly distributed. We have to change the, you can say that convert the low dimensional data to high dimensional data by make use of a mapping function. If I use the mapping function, that will take us a lot of time and costly manner conversion. That is the reason we have to convert that into kernel sphere. So we observed that kernel sphere A transpose into B whole square that will be used in the different classifications of kernel, linear, homogeneous, inhomogeneous, like that sigmoid function. So there is a different kind Gaussian kernel, like that different kind of Gaussian kernels also we discussed. In that, the short note they may ask that explain the different types of kernels or solve the problem using so on. So whatever problem, linear problem or non-linear problem, and draw the hyperplane. So all these type of questions they may ask. Now, this is the today's class, and from next class we'll start another algorithm. Any of the algorithm will start naive algorithm, or we go for a tree, a decision tree. We can use it, or KNN algorithm, anything. So one by one, these are the some of the algorithms are this unit is bit lengthy when compared to previous unit and all, because here regression classification both is there. Now we started the classifications, then we'll move on to the regression as well. Linear regression, logistic regression, there are also different kinds of regressions are there. So all these things we need to solve, but it is quite very interesting if we go on one by one, we can move on, because we observed the support vector machine problems as well. This is very simple problems. Only the data points they may give. From the data points, we have to identify the kernel space. So this is the way we can able to solve the problems. So now, if you have any doubt, you can ask me. Otherwise, we'll discuss one point when you are going to come to the college for the lab purposes and all. So in this case, we can see